final seminar of 2006 given by the Waterloo Institute for Health Informatics Research. It's my pleasure to have Bill Malyk here today. He is a PhD student in the School of Computer Science at the University of Waterloo. He has received a Master's of Mathematics degree in Computer Science earlier this year. He's been an active member of our work group, which stands for Workflow Research Knowledge Group, and is also a member of the Computer Systems Group. I guess the most important thing, though, to me is that he is so helpful in everything that we do. I always can rely on Bill to get things done, and with the enthusiasm and with great knowledge and intelligence that he goes about doing things. He leads our health informatics student group for the Institute, and so it's just been wonderful to work with him. Before I let Bill start, however, I want to make two announcements of upcoming events next year in 2007. We're going to get going right away in 2007 with Melanie Campbell, who's a professor in physics at the University of Waterloo. She'll be giving our next research seminar on Wednesday, January the 11th. And later on in January, we'll be kicking off our new Smarter Health seminar series. It's called the Why Not series. This is, if you don't know already, the 50th anniversary of the University of Waterloo. And we are following or adapting the seminar series to the university theme of Why Not. So Jake Thiessen, who is the new director of, or the director of the new School of Pharmacy and also director of the Health Sciences campus for the University of Waterloo, will be starting the series with his seminar on why not bring medications and their use out of the dark ages. I think it'll be a great seminar, and I look forward to both of them. So, Bill, will you give us your seminar, please?
Surely. Okay, I'm going to get right into things today. As Shirley said, my name is William Malyk. I just finished my Master's of Math in Computer Science, and what I'm going to talk to you today about is largely the sum of the research I did at that point and a little bit of extensions I've made since in my PhD research. I'm going to get right into things. What is workflow? If you don't know, it's essentially the composition of individual tasks into larger processes. It's the kind of thing you typically see represented in some kind of a flow chart or process map. Some examples are having your car serviced. There are individual steps which you go through to attain such a result. Performing open heart surgery is an example from the health domain. I'm going to go through this pretty quickly today, so if I'm going a little too fast for you, throw your hand up and I'll try to slow down. I view workflow as decomposition. One of the main things I see it as is breaking down a larger activity into smaller manageable tasks. Workflow is the systematic treatment of these tasks which compose the process, and oftentimes we specify some specifics about the tasks themselves. This gets into the idea of context. With each task in a workflow, each step that we go through, where the real meaning comes from of the workflow is from the who, the what, the when, the why, the where, the context which surrounds that task, the reasons for doing a specific, say, taking a specific path. Whether you made your incision into a patient 3 inches or 6 inches happened for a reason, and that reason really gives it meaning. So I like to say that context gives meaning to tasks. Workflow is granular. As we described before, we have the breakdown of one larger activity into several smaller ones. Well, this goes further and further. We have really a recursive relationship, where at the top we have sort of the macro level things, almost the business rules with which we work. Take, for instance, a process of you're applying to the university to do your graduate studies. You're going to hand in that form. That form is going to go through some kind of an authentication, and then you're going to be accepted or rejected. Each of those steps, though, is broken down into smaller ones, and at the bottom, what you really have are the individual things that people are doing, whether it's signing their signature, whether it's verifying your grades. So you have at the top level some very abstract ideas which tend to go in a sequence, and at a lower level you have the small, minute details of work which tend to get jumbled around. What is a workflow system? Well, a workflow system is really a computer system where people are typically able to engineer their own processes. That means they're able to change something like a flow chart and have the result be different workflow functionality. Different things happen in the computer based on what the individual user puts in, rather than the typical programs you see where you have a programmer rewrite the entire program. So where are workflow systems currently effective? Well, they're effective in some domains. Highly automated processes, typically called business process machines. Web-based workflow, whether it be system-oriented architectures, or web services, and banking and manufacturing are places where workflows worked traditionally. But in the healthcare, it doesn't. And why is this? It's because workflows exhibit unique characteristics. Physicians are constrained by guidelines rather than driven by rules. Oftentimes, this means that a doctor will not follow these hard and fast rules because they're simply, as we say, guidelines. And role relationships in the health domain are very intricate. It means that typically, depending on what time you're doing a procedure, it may be that your anesthesia is given to you by a nurse or by an anesthesiologist, depending on what time you're in the hospital. All these contextual effects really end up with different workflows. So what we're saying is that we have a complex and chaotic domain where traditional workflow practices do not consistently provide the solution. The bottom line is that we identify two types of workflow, what we call prescribed, which are the typical flowcharts you're probably used to, the kind of thing you can route. You can actually say, given a set of rules, what will be the outcome of a procedure. And in healthcare, we have something else, which we consider assembled workflow. In chaotic environments, you find that the workflow really exists as the history. You have a bunch of services and real-time elections which people use to produce whatever process they want. If it's a surgery, you have your doctor doing things in real time, making decisions which affect your health, where they don't consult guidelines often, and they will do what they know is best because they are the experts. So what you have is this effect where workflow as a history is valuable if you look at what happened, but trying to guide someone using a flowchart really doesn't work. So what's fundamental in my work is this idea that there's a separation between the two types. My goal is to deliver a better workflow system for the healthcare domain and to deliver better underlying theory as to how to represent workflows and how to make them processable by machine. To do this, we must make a system that supports the concept of assembled workflow, supports a rich notion of context and semantics. As we talked about before, the who, the what, the when. That's often lacking in traditional representations right now. And we need to also support the classic concepts, though. If we have a process, say billing, which is very well known and very easy, we need to have a system which can represent that in the traditional way. We can put our flowchart in, billing can be taken care of in the way we're used to, and it's only when we get into a gray area, someplace where the decisions are not so cut and dry, that we break into our assembled workflow paradigm. The outline for this presentation, I'll give you a brief overview of the method I used to come up with this research track. I'll outline the system requirements I came up with. I'll detail the work system I developed, and I'll discuss some open problems in workflow. A brief overview. Those of you who've seen me talk before, I can go on at length. So we're going to try to cut this short. A brief overview. I essentially developed the requirements we need for such a system. I then designed the system and implemented it. All right, next step. What were these requirements? Well, through a literature review, I looked at what really goes on in health, what others' opinions were, and what's sort of popular at the moment. I used the work group, which I'm a member of, the Workflow Research Knowledge Group, where we have experts who really know these things. We have Dominic Covey, we have Don Cowan, we have Paulo Alencar, we've had Ken McKay. These people were really instrumental in forming my ideas. So I searched for literature on how would we come up with, if we have a chaotic domain, how do we make sense of that? How do we build a system that's actually going to utilize what we can about the system, about such a domain? How can we produce something useful? Well, I looked at what typically exists right now, patient workflow management systems. I'll show you an example here. What you have in a typical system, this is one from '98. It's used in Italy. You'll have some kind of a workflow authoring tool. It looks like building flowcharts. You can see in the top right corner, we have a bit of a workflow language there where you're able to program in some rules. This is what you see in a guideline-based workflow environment. So someone will, say, for a diagnostic imaging department, feed in a workflow of what they want to see. The next step is that this is converted by the computer in a translation process into some kind of internal, typically a Petri net representation. And that Petri net is customized to the actual environment. So they will have a guideline for, say, diagnostic imaging. It will be different at a different hospital. So it will be customized based on the staff available and the different characteristics of the environment into your final workflow. That's what you find in a typical workflow system. But according to Lawrence, nowadays you really have three different types of workflow systems. You have this an external workflow system, which sits as a monitor on your system and tells you, say, log into Excel, do this next, go into your email. It's sort of the old school way back when, where they would just be prompted to do your workflow. They have an embedded workflow system, which acts as a monitor, much as you have in this system, which we just saw, where you build your workflow, and then you have some type of a monitor, which will push you from system to system. If we look back, just a second ago, what this really here is working, at each step, there are associated programs on your computer. Wait 7 days might trigger you to go in and activate a different program. So what your monitor is doing is passing you from application to application. So it's doing a lot of the work you would typically do yourself. Rather than you going into Excel, you going into, say, your mail program, it will actually push you from one to the next. But what we want is the integrated workflow system built around processes. In this environment, you do have your process model, as we just described, but you don't have something compiled at the end. What you have is a real-time election where the system is walking over the workflow and doing things at each step. It's not programmed to the system already, so it can discover new processes or new services as it goes along. So I wanted to build an integrated workflow system. As we said before, it very much models what you'll find in, say, traditional programming, where you have a C program, which is then transformed into some kind of internal representations, the ones and zeros, which you then have, say, an interpreter. So if we're talking about Java, you have a Java interpreter which will walk over your system. We want to do the same sort of thing with workflow. We need an internal representation which we can actually process, and we need some type of an engine which is capable of turning each of those steps. As it walks over the workflow map, it's capable of enacting each step. The question really becomes, what are the requirements of the workflow representation? So what does that internal, the ones and zeros, whatever it is that we're actually representing our system by, what does it need to look like? What does it need to contain? What context needs to be there if we're going to be able to successfully navigate the structure? And what are the requirements of the system which interprets the representation? So what characteristics does the engine need to have? So representation requirements. The first question, as I said before, what types of context do we need to represent? We've identified a few. One is that you need to have an extended notion of time. Typically in workflow, you say that a step A comes before a step B. This is a very rigid structure, and we need to have something that can better represent how time actually moves, how doing something at night is different from doing something in the day. We also need to have the traditional dependencies. We need to have activity dependencies. In some cases, you really can't do something before another because, say, you can't analyze blood until you've taken it. You need to have data dependencies. You need to have someone's age before you can make an accurate diagnosis, say, and role dependencies. You need to have the proper people there to do a job. You also have other contextual concerns. There might be value or cost associated with doing steps, so there may be one workflow which is better than another based on how much cost it takes. So our representation, this is just, I'll skip right to the picture. Essentially, this is what I think the representation needs to have. It needs to enable you to represent things in the traditional prescribed way, to draw the arrows between tasks. And second, you need to have some type of representation with value which will represent assembled workflow. It will enumerate all the tasks you could possibly do, those real-time elections, and it needs to have enough data to actually determine why you might have made a choice. What are the requirements of a workflow engine? Essentially, it needs to be able to do two things. It needs to be able to work with automated tasks, which are invoking a web service, using some type of a built-in function or procedure, or displaying a form, say. It also needs to be able to work with manual tasks. It needs to be able to prompt someone to do their job. It needs to be able to give them the resources to do it, and it needs to be able to collect the results. The most complex job is deciding when and what tasks to execute. So what we find is, this is my handy-dandy picture of a workflow engine. You essentially have your representation of the workflow itself. You have your engine, which is going to, I say understand here, that's probably too strong a word, but it needs to be able to walk over this workflow representation and do things at each step. It needs to support manual work and local automated services. Further, it needs to be able to provide you with some value. If we're saying that the workflow system is not going to be able to tell you what to do next, it needs to be able to go in after the fact using what we call workflow mining. It needs to look at what you did, and it needs to be able to, based on that, give you some kind of value. It needs to say, this was the workflow that you were trying to do, or this is the average workflow which takes place. And we have other ideas about embedded simulation, which I'll get into a little later. The big picture for health really is that we need to fit this all together. We need to have this representation which has these extra value pieces, this extended temporal representation, this assembled workflow idea. We need to have it fit into a world with a workflow engine which can do the manual processes we talked about, can work with automated services where they're available, can do the mining, and eventually can interact with an electric health record or web services. So it needs to be able to work not only in your local context but in a broader picture. So these were the requirements which I built. I use these as really both the requirements for my system but also the way I would measure it afterwards. How did I design the system? Well, I composed a workflow model and then an integrated workflow engine as described. The workflow model consists of a life cycle, stage, and task model made famous by Jackson. Michael Jackson, not the singer though. The idea is that you have a life cycle which will be associated with an entity. So if you have blood work, that will have some type of life cycle. You'll also have life cycles for each of the people involved, so for the doctor themselves, for the person who the blood is being taken from. Each of these life cycles passes through a bunch of stages, which do go in sequence. Once you get past that, though, the things that happen in each stage, the typical one we've talked about is birth, life, and death. Those things go in order no matter what. But what happens within each is a really chaotic environment. It's a bunch of things that happen in some kind of statistical probability, but you don't say for certain that one thing must come before the next. That's our essential model. We have it broken down that tasks, if things that will happen in, say, a diagnostic imaging department, some will be routed, some will definitely come before one another, but those are represented as dependencies rather than arrows where we say one thing comes after another. Why this workflow model? It has a de-emphasis on routing. It's meant to model reality. It can be implemented as data. We find, and I'll show you in a little bit, that we can represent these things using databases. Since a database is easier to change than programs, we really have this thing that rather than even going to the point of modifying a flowchart, we can go into a database and change a table. That will change all the behavior of our system. So if you think about it just in terms of programming, it's much more powerful than having to go and rewrite a C program or even to have someone who understands it. You can literally have somebody who understands a database, which we believe is in reach of most people, changing the programs. Anyways. Then we have this workflow engine. We have this idea that you use your workflow model, whether it's a flowchart or in our case it's a database which fuels your workflow engine. We have a description of the engine using rules. And the idea with the rules is not the idea of A or B comes next. We're talking about rules as in, if we're talking about an assembled workflow, what are the rules which actually allow us to assemble that workflow? So this is it's almost meta rules, really. It's not the rules in the workflow, but the rules which will determine how the workflow is interpreted. And then we have an enacted workflow at the bottom, whatever that means. It could be that our workflow, we'll take this traditional representation, so this flowchart, and compile it into a program which will be run. It could be that we're actually having services come out the end, that we have the end result of the program. There could be many different things. The result is we have a two-tiered DSL for workflow, a domain-specific language. The idea with a domain-specific language is that we have one tier where we can describe workflow in terms of entities, life cycles, tasks, the model I chose. And at the second tier, we can describe the behavior associated with each of those things. How do we deal with stage? How do we deal with a task? So we have this two-layered system where we can put two inputs in and have many different things happen with our essentially multi-purpose engine. And it gives us a sandbox for experimenting with workflows for the health domain. What does it look like? As I said, it's named after the Workflow Research Knowledge Group. It consists of this model and declarative workflow engine. You've seen the model before. Within a task, we still support the sequencing idea, so we can make this thing backwards compatible with what exists. Deeper considerations, though. Within our system, we can have local tasks, remote tasks, or complex tasks. The idea is that when we get to the bottom layer of any workflow, as I said, the very small granular pieces, we have things that actually occur, whether they're done by a person or done by a machine. We might have a remote task, which is done by what we call a web service, or we may have a complex task. This is at the very top. So we treat everything uniformly. We say, we're walking over this model, we hit a task. Is this task complex? If it is, then our system goes down a layer deeper. It builds the workflow for that, and it goes down until such time as it actually finds a piece that has to be executed and does it. Then it traverses back up the tree. Workflows can come in two flavors. As we said before, they can be assembled or prescribed, so we can support our old ideas of workflow. And our new ideas of workflow for assembled workflow in this system, they look like your life cycle model. They have the stages, but in each stage are all of the possible actions that you can do that you've defined. And at the point of, in our system, it allows the user, based on dependencies, it will say, these are the possible things you can come next. So it doesn't allow an infinite set, but it allows the set which it makes most sense. People can then pick out what they want, and it will, based on those choices, traverse down the tree. So it will, when they're finished their stage, when they've done A, B, and C that make up, say, the first step of a diagnostic image, the check-in, say. When the check-in is finished, it will, based on whatever rule you've associated with that stage, progress to the next one. An example workflow to show you what this looks like in our system, using a traditional method. I talked about diagnostic imaging a few times, an inpatient booking workflow. This is what it looks like in our system. We essentially have a first step, which is reception. These things typically happen in some kind of order, so we pick up our exam, determine type, distribute order. This should look like any other workflow you've seen, or sorry, any other flow chart. It's a traditional representation. Here we have an actual choice. You can either have a normal type of a normal exam that you're coming in for. So say it's an x-ray. You don't need anything special for it. Progress to the next step. But this is what our sort of buckets of services, which are picked in real time, consist of. They look like. Based on those, there may be subsequent behavior. So for an MRI, you've got to mark it as enhanced or non-enhanced. You'll have a doctor, for an MRI, you'll have an MRI technologist at this point, determining whether or not the person has to have it, what the duration has to be, or whether or not they have to do anything special, whether it's putting in the, is it diamagnetic material, I believe, is that? In order to actually come up with the right contrast, because the person's blood, say, can't show what you're trying to see. These are choices which need to be made because it's an MRI. Well, in this case, these choices are made based on our system. Or if it's a CT, you have additional detail. You'll finally have booking, which again, you'll see in here, there are choices. A doctor accepts or doesn't. You might have to change when the exam is booked for. All these things are built into our system. And in the end, you have this workflow which we can feed into our system as a bunch of databases and will take us through each step. What it looks like internally, we use ER diagrams to represent the model. Each one of these can be seen as a table in a database. Each one of these pieces would be one of those attributes associated with the table. So we quite literally have a life cycle table, a stage table, a task table. We can add extra pieces to it very easily. When we add a piece based on my DSL for workflow, if we want to add a new relationship, like this is the traditional, the simple life cycle stage task model. We wanted to be able to have complex tasks, which were tasks themselves, which were life cycles. We're able to add this very easy relationship by essentially, if you think about this as a graph, you could add one extra arc to the graph, and we described using our language for workflow what that arc would mean. Again, we can add extra tables to our system very easily to represent new things. We called one parentage. We wanted to have the idea that indeed sometimes one task will result in another. And this gave us our declarative internal representation. Really, we had a bunch of different sections. We have a production database which describes each time through a workflow what's happened. We have a user database which associates with rules. So we're able to have a profile of how our system actually will fit into a particular environment. Dependencies, activity routing, these things aren't too important, but this is essentially the high-level view of what our system looks like, each one of these pieces being a part of a database. What's missing from the system? Well, this is just a fancy database. We need the workflow engine, which will actually take this database and turn it into something. To do this, we saw this picture before. I'll just skip through it. What is the workflow engine? Well, that's a good question. The workflow engine acts almost as a higher order operating system for application functionality, according to Lawrence. According to Cowan, the engine is the piece of software which walks over the model and provides the functionality at each step. How do we implement this system? Well, this is what it looks like, essentially. We saw the database a little bit a minute ago. It sits up at the top. It acts as an input to our engine. We essentially have two functions the engine can do. It can initialize a new lifecycle. It can go into the database. It can pull out all the pieces it needs for the particular lifecycle. So it will form one instance of a lifecycle in the production database. It will look and say, this is stage one. It will look in stage one and figure out what tasks can be done. It will create records for all of those in the production database. We then have a bunch of views which will look inside this database and see what tasks might be available. Then, through this updating existing lifecycle function, we provide the computer with simply a bunch of PHP functions. So the PHP function for updating a lifecycle, it's a very easy system. Basically, we'll have a view which will produce a bunch of hyperlinks in our system for the available tasks. Whichever one is actually going to be executed will be clicked on, and this PHP function will kick in, which will go into our engine and update our production database based on rules which it gets from the workflow templates. So looking at how our workflow was represented, looking at the current state, we'll make certain things available. We then have this very easy function which tells us what happened. So we update the lifecycle, and that turns the crank essentially and updates our databases, keeps our system in check. How do we implement this? Well, because data is more easily changed in programs, we did this in a declarative way. We made the rules which determine how the workflow engine walks, as I said before, this domain-specific language, we made that an input as well. So we have two inputs into the system, and that gives us our functionality. I won't go any deeper than that right now. You can ask questions if you need to. And this is what our idealized system looks like.
You've implied that the workflow engine is an interpreter. It can also be a compiler as well. In other words, you can create operational code as opposed to interpreting something and turning it into operational code.
Yeah, the way we do that, it's kind of a funny little system. If you look at this diagram here, as I talked about a minute ago, really the power in all of this comes from this rule engine, or sorry, the set of rules. We have one set which is the rules for an interpreter, for a workflow interpreter. So in that case, it works much as I described, where what you're getting out at the bottom are a bunch of hyperlinks, which will then feed back into the system, keeping it up to date. In another set of rules, we have essentially the compiler rules. In this set, what you're getting out of the bottom is not necessarily, it's workflow instances, but we change the rules entirely. So what we're writing out the bottom are, for us, we're talking about web services. So we get a description of that web service out of the bottom. So we're able to, in that way, bridge a gap. You can have your workflow model up at the top. If you imagine, for those of you who know model-driven architectures, you'll have an architecture up at the top. You'll then have, typically, you'll punch a button in your system. You'll be using a case tool. What you'll generate are a bunch of stubs, which you'll then program. Well, what we try to do in this sort of paradigm I'm talking about right now is we take that workflow model at the top. We run it through our workflow engine, but what our workflow engine does, it has the rules which will then take that description and change it into what we call our compiled system, our very static system, which can then be run. It's a web-based framework, so you can literally load it up, run through the program, and you have your entire application there. And the difference between this and the typical programming paradigm is that you go back and change the model, and it changes the system. That's one of our powerful ideas. We're still working some of the kinks out, but that's where it can go. So what you can get is based on the rules. In this instance, particular instance we're talking about, what you get out of the bottom is an enacted workflow. The engine essentially has three rules. This looks a lot like one of your very basic programming ideas. It's just that you have simply a sequence, you have a conditional, and you have a loop. And the idea is that based on these and using declarative composition, we can chain these things together, and based on our workflow model, which itself is all based on containment. We have tasks inside of stages. We have, if we have a dependency, that dependency is just an arc. It's essentially a containment graph. Well, because we have that containment graph, we can very easily associate behavior with each of the elements, and we use this sort of very simple, the idea of programming the behavior using the simplest of programming constraints, which are the loops, which are down at the bottom, our if statement and our sequence statements. We put those together and we get our functionality. So the rules are described using these. There are more details available in my thesis, which I'll tell you where to find later. How do we invoke behavior? As I said before, we describe what should occur, not how it occurs, and we rely on the declarative engine to make that into an actual program. Limitations of what we've done here. What we provide, as you saw before, is essentially a database, a very hyped up database with a lot of functionality, but it lacks things. It lacks scheduler logic. It lacks the idea of what comes at the bottom is your group of tasks which you could execute. In the case where we're just using this to, say, for a surgeon, where they're going to look at the guidelines, they're going to see the few things that they could do next, you don't need scheduler logic. They are going to be the ones making those elections, so it works in that regard. But if you're talking about, say, in an environment where you're doing billing, there's nothing in the system as it stands to determine what should come first or what tasks should be passed to the person doing the billing. So these are things we need to look outside of our system for. The engine supports, it provides a sandbox for experimenting with workflow. If we find that this stage task model doesn't really work, well, it can be easily changed because we can go up one level. We can describe a new workflow model, and then using this language I provided, these ifs, loops, and things, we can describe a different interpretation we can then feed in as a set of rules. We never have to ditch a set of rules because they're just in a database. We can simply point to a new database and have a new workflow engine that easily. So it's a nice experimental workflow area. In order to add this additional functionality, to make this a really viable system, we needed to add something else, another component. We looked to the wide toolkit provided by the Computer Systems Group. It has a set of different web services. It has interactive reports. It has forms. It has the things you're typically used to seeing when you go into a website. We use that to provide our functionality at the end. So when we talk about the actual tasks at the bottom, we quite literally are stringing together forms, like say a search form. We're able to perform a listing based on that. And these things are able to give us a viable system where we can actually do something. Rather than simply look at database tables, we're able to enact a workflow. To go a little bit further, we wanted to do two things. We wanted to be able to provide, you can dump out your description of workflow. Right now it sits in a database. You can dump it out as prologue statements. So you can do things like ask questions about the workflow that's sitting in your system that you created. And you can also use XML transforms to say, at one point we have an idea of mixing in aspects into workflows. So you have a typical, say, a macro almost of what should happen when a workflow will be elected, say. So in an aspect-based area, an assembled type scenario, you might have specific rules that come into play because it's an emergency situation. You might ditch all of the things that aren't considered important, and you might have an importance associated with each workflow. Well, we can use XML transforms to alter our original workflows to represent that. It's a little more technical than that, but I won't get into it too much. The payoff really of what we've got with this system is that by adding in this extensibility, we're able to do things like workflow mining. When I talked about punching out a prologue statement, if we have our system, as I talked about before, which has these buckets where you're able to make these choices, we have a production database which is always logging what has happened in these instances. We can then go into that production database, we can export it into something like Prolog, and we can start asking questions. And I've asked very simple questions right now, but the ability is there that someone who's an expert in mining could go in and do something useful with some of this data. It enables delta analysis, which is to look at what the workflow was you intended, what the workflow is that you actually got out of the system. So there's a lot of payoff in doing it this way. I'll skip over the evaluation stuff here. The results so far is that we have a workflow system which, while not complete, we are able to integrate with the wide system to provide some functionality, use this Prolog integration XML output, and we get a robust framework on which to build some systems. We have a very good sandbox in which to do experimentation for the workflow group I'm a part of. And we have this nice idea of assembled prescribed workflow that's come out of this work. We have a rich treatment of user rules in the actual system. And I put a little star on the bottom, handles cross-cutting concerns, something I'm going to talk about in a second. But contributions are this, that we have really a blueprint for providing a workflow system. I'm not claiming that my system is the ideal solution for health or even for any domain. But what we have is really the tools with which to build such a system. That if we had someone go in and analyze a domain, they could set aside the elements they think were important in such a representation. They don't have to stick to your current flowchart paradigm. They can then go in and provide recipes for how to, well, I say recipes for extending the workflow model, but they could have recipes for how to interpret the workflow model. And they have a system which they can reuse in many different domains. The workflow system itself is flexible, as I've said. Let's see. What do I want to say here? I see the biggest contribution of this, though, as being that extensible system with which people can go in and make their changes, and the most powerful thing being that they can change data to change the system rather than programming. Future work. Well, in general, what we'd like to do is provide a formalization of these DSLs, those domain-specific languages. We'd like to be able to provide someone with simply the recipes for how to do this and the system and allow them to go crazy on their own and provide back a set of data, essentially, that will run the system in different ways for different purposes. It's almost a open source mentality where we control the system itself, the interpreter, but people are able to contribute by changing these two inputs, the set of rules and the way the workflows are that come in. And future work for ourselves, though, the idea of aspect-oriented workflow is something that is interesting to me. The idea of a middleware solution, which we mentioned previously when I talked about the idea of taking your map of your website and producing right from that the actual operating code, is this idea of a middleware solution. And the real-time prediction of assembled workflows is another. Let's see. The most interesting one, the one I haven't really talked about here, is this real-time prediction idea. As Covey has actually suggested, there's this idea that we have hypotheses of how workflow should really be conducted. When we're conducting a surgery, based on mining, this idea that we can look at what has occurred, we might be able to predict how people typically go about doing a surgery. We could have the most likely hypothesis offered as advice to a surgeon, whether this be on some type of overlay, as some type of audio, prompting the user that it looks like you're doing this. When the surgeon deviates from that workflow pattern, we look at the next most likely hypothesis. It's this idea that there are more than one workflow going on at a time, and that if we're going to provide value, we might be able to pick up where they are in the workflow and then make some kind of a prediction based on where they might be. Some open problems. One question, when I say assembled workflow, it's this idea of dynamic workflow. What is it really? We've got some notions of it, and it's come out of this, but really no one knows. There is definitely a difference, though, between the flowcharts that people have used and the type of workflow we're talking about, and we need a formalization of really how you get from the start to end in a process and what's going to be valuable. It seems that things are pointing to the idea of context being that you have a universe of workflows, and the context helps you chisel down to those 4 or 5 which may actually occur. And how to represent context then becomes one of the big keys to realizing something that's useful from dynamic workflow. My idea also is the mining idea, where you almost go from the end to the start, where you look at what happened in your system, you have the proper recording, the proper capture as things go on, and you're able to generate from that, sort of answer questions about what and why things happened based on mining out the context in them. This idea of multiple flows. There's an actual workflow, what occurred. There's the ideal workflow, which is what you intended. Typically, people talk about a delta analysis where they look at what actually occurred and they think about what they wanted to occur beforehand. That's a delta analysis, but there's a lot more to it. There's this idea of a cognitive workflow, that if this were all a surgeon, I like to use that example, but they had an ideal. They had, say, the guidelines they were supposed to enact. They have the actual, the things that happened. Along the way, though, they have a real decision-making process. Why did they make these choices? Well, as we pointed out, or has been pointed out to me, no one's really looked at that. This is sort of one of the places of future work that would be really important, and it's how to reconcile these pieces, how to put them together. And idea of cross-cutting concerns. There's this idea that things reoccur in software. People talk about aspect-oriented programming systems. They say that logging occurs all the time. So why not factor this out in a way? Put it over to the side, build a recipe for how to deal with this concern of logging, and apply it when it's actually useful. So we have certain pieces of data in our system that might need to be logged. Well, we'll have basically a little interpreter which will look at our code, say, okay, this piece of code needs to be logged, or this transaction needs to be logged. Let's jump over into this recipe and run it. Well, when we look at workflow, the same sort of things happen. That based on the characteristics of a task, it might be run different, as I said, based on context. When it happens, why it happens, how much it might cost. Well, if it's going to be an expensive procedure, we might want to kick in, say, a logging situation. So if it's real life, we might want to have a very expensive audit trail going on because it's an expensive procedure. That's going to be an aspect, and how do we mix that into our system? So this is one of the future things we would like to look at. To wrap up, I'd like to thank my supervisor, Don Cowan. I'd like to thank the work group, in particular Dominic, who has really given me a lot of ideas as far as how workflow actually works in the real world. So, and then the computer systems group, which provide me with the infrastructure to build some of these systems. And thank you.
So we have time for questions. The only thing I ask is give me a chance to get the microphone to you for questions and comments.
You use the Jackson model, Bill, and one thing you and I have never talked about, and I just wonder if you've thought about it. At the end of his book, as well with any model, there's always a few, quote, exceptions, things that don't quite fit, but you kind of shovel them off the side because it works most of the time. And have you thought anything about those exceptions and what they are?
Well, in one case, to give you a bit of background for those who don't know, the Jackson book from which I got this model and really what sprung the ideas of using a life cycle approach, it's one breakdown that works nicely in their book. They talk about it as an idealized way to look at workflow, this birth, life, death, things don't cross over. But once you get into really how their system works, and it's a system for banking where things many times are cut and dry, they start to think about, well, really, if we're talking about, I'll use an example, they're talking about getting insurance, an insurance policy. You apply for the insurance policy, they start to look at different factors involved in deciding how much you're going to have to pay. Then eventually you do the payment. These are 3 stages. Well, they say that there's no reason why they should be stalled by something like missing your home address when they're going through the second phase, which is the actual taking a look at what your insurance rate should be, whether if it's health insurance, say. So they say, well, let's relax these restrictions a little bit. Just because we're still in the first stage, we still haven't done some tasks, we should still be able to go on. And the Jackson model becomes this sort of guideline itself rather than a rule on how these things work. So when I was trying to build something that essentially it's a system which is trying to be able to automatically make some choices for you to run through, it gets more and more complex the more of these exceptions you try to allow. So my way of dealing with this was this aspect idea that we should tag things as we go. We should say the characteristics, which gets to the idea of context, which I haven't really explored very far, but gets this idea that you should include as much context as you can with these tasks and allow the exceptions to be treated sort of on the side, that you write recipes for each exception, and then you can systematically apply them when, say, a couple of tags, a workflow is marked critical or a workflow is marked costly, that these things are in place. Well, that's when we jump into this other space, when we mix in this recipe and then allow this computer to systematically take over for these exceptions. So that's sort of my thinking, but at this point, that's as far as I've got.
Other questions or comments?
Are the dependencies in the workflow strict dependencies, or can you have priority for dependencies? So, for example, you have a bucket of tasks, and maybe some of the tasks would like for some data to be available, but it's not necessary. So, like, how would you then present those tasks? Like, I'm thinking in healthcare, like, sure, if you have all the information, you can make better decisions, but sometimes you require some information. Other information would be nice to have. Like, is there any way to model that?
Well, yeah, there is. Very easily in our system, I got to the point where I decided dependencies for me anyways to model these workflows in the diagnostic imaging domain, which I looked at. We really ended up with 2 dependencies. We had this idea of one task has to, one task has to be preceded by another. Then we had this idea of, I called it parentage or spawning, that one task will spawn a whole chain of things that have to happen after. So that was one dependency. And the other one was this data dependency, sort of what you're talking about, and a little bit like the Jackson idea where a piece of information is missing. You can't do this task until you have it. So I looked at these two, and I started to think of how to generalize this. And what I ended up with was just one database table which had, first of all, what the two tasks were which were related. And then I ended up, to extend the model, I used my little DSL for workflow. I decided, well, I need some other kind of characteristic to fuel my decision. I said, well, a new context is going to be, what in the world is this dependency? Is it going to be almost a forward dependency or a backward dependency? So I was able to really quickly add a new field to my database, which simply type. Have those two types in there, and write a couple of rules for my engine, which were saying that if we're invoking a task, check its dependencies. If it has this dependency, present however you want to do it. Modify it in whatever way. For me, it was simply, if the dependencies are met, you can't display it to the user. So it was sort of like a state machine in that way. You better put it on a waiting. Sorry. Cool. You better make it wait. That was what my system was doing, but the DSL is there so that when you need that kind of characteristic in your workflow, when you need to make that sort of extension, you can do it, and the recipes are provided.
Other questions or comments?
Hi, Bill. You talked about how your assembled workflows are really the emphasis on how workflow in healthcare is actually history, right? So in your system, what level of support do you have for actually being able to capture and record real-world instances of workflows? And secondly, is there a notion of a feedback loop where after, let's say, you've monitored 1,000 iterations of some particular process and you realize that 90% of the time a particular workflow stands out or a particular orchestration stands out, and that feedback loop will actually indicate that workflow can be prescribed in a way? Is there a notion of that?
Well, that's the ideas, but my workflow system right now it's a tool with which to do the experimentation. So we don't have it running in any hospital where we could actually go in and mine these things. But we have the ability, as I said before, it's basically been a demonstration that some of these techniques can work. I can see very easily though, this idea of a real-time, say, system check or whatever you want to do, a mining, where we could, in any case, if we, say, had our bucket of tasks, going back to the last question, where we wanted to have a certain dependency, say, weighted, that we could use our mining to determine what people were really doing, that you present something. Maybe that's the way in which you determine what those weightings could be on your dependencies, rather than simply looking at, okay, now we need this piece of data. It's a hard and fast rule that people decide ahead of time. I think that really the value is to look at it later and decide what the dependencies are, to look at what people are really doing. And it's almost that, okay, the doctor always goes ahead without this type of information for this next task, and that maybe you have a set of dependencies between these tasks that you're changing the weights of. All these things are possible in the system, but you're right, we don't realize them yet. But the idea of a feedback loop is, I think, an amazing addition to this.
Other comments? Other questions? If not, it's one back. Tricia, can you raise this up?
I'm Patricia Berta, and my question comes from having a background of working with vendors of imaging modalities as well as software for clinical decision support while prescribing imaging tests. And I think the workflow engine that you're presenting here, if it comes to life and is implemented in the healthcare system, can be a great contribution to healthcare in general. My question is a bit practical, and how do you envision, given the legacy systems that you have in hospitals with radiology information system, PACS system that have a technology that's based on designs from a number of years back, how do you envision this to be working in the real life situation of a healthcare system, of a hospital?
Okay, let's see if I can go back to one of my earlier pictures. So this is what I called the big picture of workflow. And this is when I was developing my requirements. I had this idea that really what you have below this line almost is your internal system. You have the different workflows that exist in, say, your department. And outside, and then you have this engine. But the engine itself has to be able to work with these, I said EHRs, I said web services. It has to be able to work with any legacy system outside. So I tried to, when I built this thing, there's an evaluation step in here, which I skipped in the interest of time. I looked at they call it the workflow reference model for these systems. I can show you one nice picture from there if you want, but essentially what you have in these, the way that they looked at all workflow systems was they wanted to have some kind of a standard. So they had a 5 interface model, which they said that systems should be able to interact with for the last 10 years. They use this as almost their gold standard. Let's compare our systems to it. There are recipes you look at for how to make your system compatible with this model. And I looked at those when I was developing my system, and one of my evaluations was, can my system sit inside this box and do these interfaces? Is it possible for them to connect? And there are almost too many threads in this work for me to follow them all, but I got to the conclusion that I believe that it can fit this model. And if that's the case, you can then follow the cookbook approach to provide a standard interface between these systems. If the reality is that the workflow systems are so old that they don't have any type of standard interface themselves, then that's a different problem. But I was trying to go forward. I would imagine that, or I'm hoping anyways, that you can find, if you were to look at these old systems, you could find a mapping between the old school, if it's a flow chart, and the representation we use, that there would be some type of mapping possible there. And we would like to think that there might be a mapping between many of the typical representations, that if we're using a richer one, that you could find that. But that's the sort of thing that I haven't gotten into myself, but I'm optimistic anyways.
I think largely, I think the sense is we're projecting this as a new way of writing systems and creating these kinds of systems. And as you know, there's been a lot of motion in the marketplace about this. Also, vendors are having a significant problem with their systems and getting appropriate behavior, and also, I'll call it timely responses, or high performance is a better word for it. So, but I think this is more an architecture for the way to go in the future, although any service could be a system, and a service could be called by this, so a system could do a certain service, but it doesn't work that straightforwardly with current technology.
Just to comment on that, I'm in the electricity and power generation field. I've been working in that as a consultant. We've had to wrap a lot of legacy systems with web services because it's stuff that's been proven to work, and they're not willing to change it out for a new system. So just put a wrapper around it, and that's been their answer for a lot of things.
What was the quote? I heard it was something that a legacy system is one that works. That was sort of one of my favorite quotes I heard, and I can't remember who said it, but I thought, wow, it's wonderful, and maybe that is the way to go in some cases. But I think that some people are just resistant. You're right, that they've used it for so long, and if it does work, why fix it? So I don't know if that's the future, but as we see it, one of my little hopes is that we can interact with the web services.
Any further comments? I just want to ask Frosty here. Frosty, do you have any comments?
No, it was a great talk. I'm sort of cold to workflow, though.
Thanks very much.
Thanks.
Yes, so I invite everybody to stay for our social time. Just give us a couple minutes. We've got some beverages for people to drink, and some goodies, cookies, Christmas cookies, and Christmas cake, and chips, and other stuff. So please stay with us. And by the way, we have something that maybe people would like to have. We've got a box at the back of T-shirts. You're more than welcome to take one. When we had our last boot camp in Edmonton, the university, I think it was York University, wasn't it, Colleen, provided everyone with T-shirts, and we had extras left over. So you're more than welcome to have one. It's our little Christmas present to everybody. Please feel free to take one. So thanks for coming out today, and we'll see you in January.